Okay,
Okay, I
that
thought it was
makes
because
sense.
Okay. Find sine and tan if cosine is 1/2. So cosine is x and tan is y over x. Okay. So I'm going to make my little coordinate here. And this says x is a positive. And what I do when I am given tan, I put the positive or negative on the thing that I have, and then I use that to figure out the other one. So it says tan is less than 0. So that means this fraction has to be negative. If the bottom is positive, then the top has to be negative. So y has to be negative. That's how I figure it out. And this would be quadrant 4. Positive and negative is quadrant 4. Okay. So cosine is the x, that's 1/2. Hypotenuse is 1. And I want to solve for y, which is sine. 1/2 squared plus y squared equals 1 squared. 1/4 plus y squared equals 4/4 minus 1/4 y squared is 3/4. I can't believe that neither one of the students that I thought were going to have their hand up this whole time don't have their hand up. Okay. Square root. I can't believe that a certain student in this room is just letting me go through with this. Y equals plus or minus. Okay. So square root of 3, square root of 4 is 2. I can't believe that that person is still just letting me go on. I'm just so shocked with the fact that no one in this room is speaking up. Anyway, so why we want the negative one because we're in the fourth quadrant, the triangle is going down and y is negative. So I'm going to say sine of theta equals negative root 3 over 2. The amount of work this student is costing me right now is just, I don't, just refusing to speak, but I'm just still going to keep going. Okay. So I got sine. And now I guess I'll do tan. Tan equals y over x. Y is what I found. Oh, yes, sir.
the other angle just for the side and one is the other one half of the 90 degree.
No. If it was a 45, 45, 90. Uh-huh. Why isn't anybody saying this is a 30, 60, 90 and I didn't need to do all of this work? Isn't this a unit circle one? Yeah. Okay, but we're almost done. Now, also, this is my favorite kind of tangent because when I cross out the 2's, the root is on the top, so I don't have to rationalize anyway. But those were already on your unit circle, and we probably could have just figured it out with the 30, 60, 90. But the one on your quiz next week on the block day is not a unit circle one. You have to go through the motions, so I wanted to practice it. Okay. Now go down to number 4. And because this is negative, I'm going to label this in the negative direction. So 0, -90, -180, -270. Everybody okay with my labeling? Okay, and if it's -205, I'm gonna go start here, -90, -180, and it's gonna be like a little bit past that. Does that make sense? Okay, so put it like here-ish. Wow, my degree symbol is proportionately very large. Okay. Okay, now you're going to ignore the negatives and say to yourself, how far away is that arrow from 180? 25. Great job. So the reference angle is 25 degrees. Okay. Okay, so quadrant 1 is 25. Quadrant 2 is 180 minus 25. Quadrant 3 is 180 plus 25. And quadrant 4 is 360 minus 25. Okay, and then remember when you're doing coterminal, you start with the angle given to you in the problem, not the reference angle, so the original angle. And to make this positive, you add 360. Which is 155. Hold on. Having some packet control issues. Now, does it make sense from your picture that a positive coterminal angle to -205 would be 155? Look at the labels. Okay, just want to make sure we all understand. Okay, and -205 minus 360 is -565. Okay. Are you feeling better about the negative angles? Okay, in degrees at least. Notice number 5 and 6, we're gonna have a rad time next week. Get it?
Yeah.
Okay, you're done with your packet. You can put that away completely. And then I just kept going in my notebook after number 2. So that's number 2 at the top, and then there's the start of today.
This is like.
Are you guys okay? Okay, first thing I need to do is tell you that there's no way that I'm gonna finish all of number 6. I'm gonna get through 6A today. The reason I'm telling you that is because I'm gonna do 6B and C on Monday, but I want you to leave me some space in your notebook. I'll tell you how much space at the end of at the end. But don't worry, when we start to get close to the end and you're like, oh my goodness, is she gonna finish? The answer is no, I'm not going to finish. I already know that. It's okay, because the stuff we're doing on Monday is short. And it's this the whole TPP deal. Okay, first thing we need to talk about is vocab. You know how like sometimes in math, you have two vocab words and they sound really similar, but you don't know which is which. Okay, in math one, you learn sequences. Sequences are number patterns with commas. In math three, you learn series. Series is the same sequence, but instead of commas, it has pluses, and you add them all together and get an answer. We did an arithmetic series up there in B. I still have it showing. That was your first arithmetic series. And when we did it, you guys are adding them up on the calculator, and I was like, there must be an easier way. And then I said that's what I was going to teach you today through a history lesson. Okay, except for that I'm bad at history. You'll see just how bad in a minute. Okay, an arithmetic series is the sum of an arithmetic sequence. And it has an answer, which is the total, basically. Okay, now I'm going to tell you the easier way to add up the numbers through history lesson. About a mathematician named Gauss. Okay, but I have to warn you, the history part of my lesson is all wrong, because I took the history of mathematics class. You have to take it when you're a math major. And I only remember the parts of it that I got an emotional reaction from. I don't remember anything history. So my story is going to be fun, but it's going to be really, really wrong. This isn't it? Fine. I don't know, and I'm in the middle of teaching over here. Yes. That's perfect. Thank you. Sorry. Bye. Yeah. Substitute having trouble with the class. Okay, anyway, Gauss. Okay, this is one of my favorite stories. I'm gonna completely ruin it, but the math is gonna be correct. That's okay. Okay, Gauss was a little super naughty genius boy. And he lived in a certain amount of hundreds. I don't know when. I can't remember. And I don't want to know because my story is funnier if I mess it all up with the history part. Picture little Gauss in his beret and cape. I got it. And he's in a classroom, probably all full of dudes with a dude teacher at that time period. I don't know what time period it was, but it was a long time ago. And the teacher, was irritated because Gauss was naughty. And he finished his work really fast and then bugged the teacher. That's all it was.
Did Gauss yell at the computer recording methods?
No, probably not. I think that technology wasn't quite there yet. But he might have just yelled when the teacher was trying to teach lessons. Anyway, so the teacher had this evil plan. He was like, I'm gonna send Gauss back to his stool, table, desk, chair, and tell him to add up all the numbers 1 through 100. And he's like, that'll keep Gauss busy for a long time. Except for that Gauss went back to his chair, table, desk, and got out his quill, chalk, charcoal, stone, and his scroll, papyrus, tablet, paper, and wrote down something really fast, like scribbled it, and then came up and handed it to the teacher right away. The teacher's like, oh no, this is correct. Okay, let me show you what he did, little smarty. Okay. So Gauss put on his scroll paper. When is papyrus? Papyrus is like BC, isn't it? Yeah, okay. Anyway, so he went like this. He said 1 plus 2 plus 3 plus ... plus 100. And then underneath it, he wrote 100 plus 99 plus 98 plus ... plus 1. And then what he did was he treated these all as separate addition columns. So 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. And 100 plus 1 is 101. I think we can all safely assume that all of the columns would add up to 101. So Gauss said the sum of the numbers from 1 to 100 is 101 written 100 times, but I have to divide my answer by 2 because I wrote the series twice. So he said I have 100 101s, but since I wrote it twice, I have to divide by 2. And this is 5,050, which is a much faster problem to do than this problem. Okay, today in 2026, we say the sum equals n over 2 first term plus last term. This is Gauss's formula. It's just that we've rearranged it slightly. N is the number of numbers you are adding. This, in Gauss's case, that would have been 100 because he was adding 100 numbers together. This would be term 1, and this would be the last term. Term 1 being 1, and the last term being 100. When you add those together, you get the 101, which is the 101 from each column. So it's 100 divided by 2 times 101. 100 divided by 2 times 101. Okay, we're going to use Gauss's formula to figure out how much money Angela had in her savings after 18 years. So sum equals. Okay, so let me ask you a question. How many total months did Uncle Zachary put money in the bank for her? How many total months? Look back at the top of your page. How many total months did Uncle Zachary put money in the bank?
Interesting.
216 divided by 2. And what was the very first amount that he put in the bank? 50. And what was the very last amount he put in the bank? You have it. Yep, 695. It's back up in your work there. And so he saved for her $80,460, which I think in 2026 would really only get her 2 years of college, not 4. That's how much prices have gone up. Still, Uncle Zachary is awesome. Okay, I'm gonna flip my notebook over to the other side to start number 4. So depends on where you're at on your page. If you're in space savings mode, you might have been able to fit a lot more than me. Okay, number 4. When an arithmetic series has many terms, adding them one at a time can be tedious. Having other strategies to calculate the sum is useful. To look for a strategy, consider a new situation. Flo is preparing to run the 100-meter race at her next track meet. Her coach decides to collect data to see how well Flo is accelerating, speeding up at the beginning of the race. The sequence below represents approximately how far in meters Flo travels during each second of the first 6 seconds of a practice race. Okay, this is the sequence we're going to write down next to 10-4. Right next to where it says 10-4, can you please write this sequence down? 1, 3, 5, 9, 7, 11. Okay, now for A, it says write an equation to represent this sequence. Okay, I'm going to do the equation 2 ways. I'm going to do the equation with term 0, and I'm going to do the equation with term 1, because I want to review what I taught you yesterday about how to write it 2 different ways. You don't have to write it 2 different ways, but this is just me, reteaching what I did yesterday afternoon. So I'm going to come back up to the sequence, Amazon arrow, backwards arrow, and I'm going to say the growth is 2, and term 0 would be -1. Does that make sense? Everybody good? Okay, so the term 0 equation would be T of n equals 2n minus 1. So growth and then term 0. The term 1 equation would be T of n equals 2. And then instead of just n, you make it n minus 1 to go back a spot. And then you add, I was doing the last example. Then you add the first term instead of term 0. Okay, check in your mind. Do these things equal 2n minus 2 plus 1? Yes. Okay, so when you're doing term 1, you don't put n, you put n minus 1, and then term 1 here instead of term 0. Okay, now B. B says, what does the related series, they changed up the vocab word on you because this said sequence. Now it says, what does the related series represent in this situation? What is a series? The sum. Okay, so the series is 1 plus 3 plus 5 plus, whoa. I mean, technically, everything's included there. Mm-hmm. It must be toward the end of the day. I mean, I had them all somewhere. Anyway, what was this? This was how many meters she went in the first 6 seconds. So 36 meters. That was special. Very special. Okay, C. Flo's coach decides to use square tiles as shown in the diagram below to represent Flo's distance from the starting line as time passes. So there's her first second, second second, third second. Look at how fast she's going. It's great. Okay. I don't know why a coach would do this, by the way. I feel like no coach would actually do this, but whatever. Flo's coach rearranges her tiles on a graph like the one at the right. How are the terms of the sequence shown on the graph? How is the series represented on the graph? Okay, this is a vocab question again. So they're asking, how do the terms look on the graph? And how does the series look on the graph? So we need to make sure we understand these vocab words. The terms are 1, 3, 5, 7, 9, and 11. Okay, so let's go back to the picture. How are 1, 3, 5, 7, 9, and 11 represented on the graph? The heights of the bars. The heights of the bars. Okay. How is the series represented on the graph? The series is 36 meters. How is 36 meters represented on the graph? Let me give you a hint. How is 36 meters represented on the graph? I just highlighted the answer. Yes, it's the area of all of the bars. Okay. D. Determining the area of the long rectangle flow has made in part C requires adding all the sections. However, if the columns and flows graph can be rearranged to form a single rectangle, its area can be calculated more easily. Discuss with your team how this can be accomplished and be prepared to share your ideas with the class. Okay. This problem would have been much better if the book said Tetris that shaped into a rectangle. If they used the word Tetris, everybody would have gotten what they meant. But they didn't use the word Tetris, so now it's all confusing. Let me explain what Gauss did. Let's explain Gauss's Tetris. Okay, Gauss didn't do this, by the way. Also, could you imagine how amazing he would be at Tetris? Just saying. Okay, so Gauss said, okay, I have this. I'm gonna make a copy of it and put it over here. So now I have two of them. And then I'm gonna take my copy and pick it up and put it upside down on there so it makes a rectangle. That's what Gauss did. That's a visual representation of Gauss's formula. Does that make sense? Okay. Now what we're gonna do is we're gonna say, what could I do to this picture, assuming the bars have to say bars, to make this a rectangle without doubling it?
We're going to the left one.
Yes, okay, but how about I'm gonna do what you said, but the opposite. I'm gonna take the last three, cut them off, flip them upside down and put them right here. Can you guys see that?
Yeah.
I'm gonna take these three bars, cut them off, flip them upside down and put them there. Okay, if I did that, what would the base of my rectangle be? 3. And what would the height of my rectangle be? 12. And what is 3 times 12? 36. Just like the series that we got earlier. Tetris. If they would have just said Tetris, we would have been fine. Okay. Okay. So in 105, we're going to use that concept to practice Gauss's formula. So we're going to write this just one time, mostly because I want to have it on this side of my paper. Okay. And here is the graph that we're looking at. I want you guys to look at the bars. Can you tell that this is saying 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5? Can you tell that that's what that's saying? Okay. How many numbers am I adding up? 7. Okay. So on your paper, write sum equals 7/2. We're adding up 7 numbers. What's the first number? 5. What's the last number? No. 5. Okay. I'm gonna do B with you, and then I'm gonna have you guys do C and D. Okay, here we go. Take a look at B. How many numbers am I adding together? 16. Okay, so write on your paper, sum equals 16/2. 16 bars, 16/2. Okay. And what is the first number? 4. So put parenthesis 4 plus. And what's the last number? 10. Which is something that is 112. Okay, I want you guys to try C and D in your groups, please.
That's a 51. Yeah.
You can type it in one fell swoop. Just use parentheses.
What's your question? Why do you think plus 40? I have 15, 2, 15. I have 4, 6. I have 6. Just how it's 6, is it 6, or C is 6/2?
6 bars divided by 2, first bar plus last bar. It's 32. Yeah, there's 32 bars there.
Yeah.
That's a 36.
Yeah.
All right, guys, take a look at mine. I got 828 and 544. How do we do? Okay, last problem of the day, number 6. And remember, I'm not gonna have time to do B and C, but I want to tell you that B and C are going to take the exact same amount of room as A. So when you're leaving me room, leave me the same amount of room that you're gonna leave for A, but I'll do A first so you can see. So those problems were really easy. Those were baby ones. The actual math 3 problems are going to have you run into a problem. Okay, this is the type of problem that you should encounter. These are not as straightforward. So sum equals n over 2 first term plus last term is what I want to find. I says find the sum, so I wrote the sum formula. Sum equals, and then I noticed that it didn't give me n in my list of numbers, or my list of information here. I'm going to leave that blank. Say something divided by 2. But I do know that the first term is 18. And I know the last term is 72. Okay, does that make sense so far? Okay, so what I do when I'm missing a piece is I will draw the sequence or the series out, and then I'm going to find the equation. The equation is basically a calculator. It will give you every single term and every single term number. Whatever you want, it will give it to you. So this is telling me that the first term is 18. This is telling me the last term is 72. And this is telling me that the growth is 4.5. Does that make sense, my picture? Okay, so I know this next number is 22.5. And I don't really care about any of the numbers in the middle, honestly. But I do care about term 0. Because I like to write my equation in terms of term 0 if I can. So this one in front would be 13.5. Are you guys with me so far? Okay, so my equation, which is basically my calculator of everything, is T of n equals 4.5 n plus 13.5. Okay, what I can do is I say, all right, I want to know what spot 72 is in. So I plug 72 into T of n. And then I can find n, which is what spot it's in. It's a calculator for everything. Oh, so that means that 72 is in the 13th spot. And it also means that I would be adding up 13 numbers. The equation fixes everything. So the sum of this is 585. And there will be people on the test who will write 18 plus 22.5 plus 27 plus all the numbers up to 72 and add them together. And I really can't stop them from doing that unless I say, n is like 592 or something. That would be rough. Okay, you guys see the size of 6A? Okay, so leave me 2 more of those sizes for a B and a C.
Just how, we can have space.
Yeah.
What rule,
Maybe. Hi.
Hi, everything okay?
Yeah,
Yeah.
I was really confused at first, but I figured it out.
It's not the easiest.
Well, like at first you're like flipping around.
Oh.
I was like, flipping around, oh no.
Just like meant, make it into a, yeah. The whole chapter is formulas.
Yeah. Oh, yeah, no, yeah. Very awful.
You was like in a bad mood today, bro. You're yelling at everyone.
The chapter 10 to chapter 9 is
Yes.